Hello geometry students, and welcome to a video that's going to show you how to do dilations in synthetic geometry. So now we can make something larger or smaller without the coordinate plane. Okay, so first of all, just look at a couple of diagrams here. These two pairs, this pair of images, they look like they're the same shape, only a different size, which is pretty much what a dilation is. So if this were the pre-image, it looks like it's increasing. Maybe it's 3 times as big. We don't know exactly, but it looks like it's increasing. And these look like they're not the same shape, right? This is a shorter triangle, and this one is the legs. Like if this is a right angle and this is a right angle, here the legs look like they're the same length. Here they're different lengths. That pretty much rules it out from being the same shape. So these are not. This is not a dilation. Okay, so what we're going to do is we're going to look at how to make a dilation with just a ruler and a point. Now, a dilation has to come from some point. And when we worked on the coordinate plane, the point that we dilated from was always the origin. We always had that. Now, we have to have a point as well. So this is going to be my point of dilation. In other words, this pre-image is going to grow from the perspective of this point. And that makes the process really easy. Okay, so we're going to dilate the pre-image from P, making the image 2 times as big, which means it will have a scale factor of 2. And then we're also going to make it 3 times as big, which means it will have a scale factor of 3. So let's see how we do this. The first thing that we're going to do is we're going to make a line from the point through the important points of the figure, which are the vertices of the figure. So I'm going to go through Z first. And I'm going to make a nice long line there from Z. It's going to go right into the writing, okay, just up to there. Then I'm going to go from the point to Y. And I'm going to make a nice long line from Y, through Y. From P through Y, there we go. Now I'm going to do the same thing from X. From P through X. And there we go. Maybe a little bit longer even. And then from P through W. From P through W. And it looks like right about there. And that's it. Okay, so that's the first step. Now we're all ready now to draw in our dilation, but we just need to use our other tool that we've used quite commonly, which is a piece of paper. So you take your whatever paper you've been using to measure. You can use a ruler, but as you know, I prefer to do this on paper. And the first thing we're going to do is we're going to look at the distance from P to Z. So from this point here to this point here, I'm going to mark it on my paper. Now that is going from P to Z. That's a scale factor of 1. Now watch this. Now it's a scale factor of 2. So if I were to put my Z out there, it's gotten twice as big, right? I may as well put my other one out here and make it 3 times as big, because I'm going to do that with the figure as well. So I'm just going to do that same process with Y, with X, and with W. I'll do one more with you, and then I'm just going to kind of pause the video and have you finish it up. So here it is from P, from right in the middle of the point P to whatever that point was called, and that was Y. All right, that's a scale factor of 1. From there to there is 1. Now I'm going to double it from the point to this spot right here. That's a scale factor of 2. And then from that point, one more time the same distance, that would be a scale factor of 3. Okay, I'm going to pause the video and do the other 2. Okay, now I've got a whole bunch of points. Now what I noticed, by the way, is that the length of PZ right here from P to Z is the same as the length of P to X. So that made it a little bit easier. The process was a little easier. And from P to W is the same thing as it was from P to Y. It just makes the process a little bit easier. All right, now what we're going to do, if we can kind of keep track of what came from what, is we're going to connect these. So this point right here, I'm going to call that Z prime. This point right here came from Y, so I'm going to call that one Y prime. This point right here came from X. I'm going to call that X prime. and then this W went over to here, so I'm going to call that W prime. And now I'm going to connect my primes. So I'm going to pause it and let's see what we get after we connect it. I'll just connect all the primes. It won't take that long to do it. So here's the Z connected to the Z prime connected to X prime. And then here's X prime connected to W prime. The more careful you are with the ruler, the better the effect at the end and it looks right. Otherwise, it sometimes doesn't look like it's the same shape, only larger, but it looks like a different shape. So there it is. And you get this three-dimensional effect when you look at it, but you've got the point, and then there's the pre-image, and then there's the image under a dilation. This is now twice as big as this. And if we were to measure every side, if we did this accurately, and we were to measure, let's say XZ, looks like it's about 1.2 centimeters. Well, X prime Z prime would be about 2.4 centimeters, about twice as big. Okay, so that should happen with any corresponding length. Now let's just go ahead and call this one, this was Z prime, this one is Z double prime. Let's call this one Y double prime. Let's call this one X double prime, and W goes over to W double prime. W double prime. That's hard to even say. All right, so here we go. Let's connect them. And again, I'm going kind of fast here. That makes a little dent in the accuracy, but this is a video. We don't want it to go too long. So there you go. Now you've got this image is 3 times as big. So whatever this was, this X double prime to Z double prime would be 3 times as long. Whatever XZ is, X double prime, Z double prime will be 3 times as long. So this one has a scale factor. This is K equals 2. That means 2 times as large. And I guess we'll leave it at that. This one has a K equals 3, which is 3 times as large. I think I'll just write the word just so we can be clear. 2 times as large, 2 times as big, same thing. Means scale factor is 2. And this one, we'll call that SF, is 2. This one has a scale factor of 3. 3 times as big as the original blue here, the bigger font, the thicker line here, the pre-image. All right, now we're going to do something that's a very free activity. And that is, you're going to draw your own image. It can be a block letter of your initials. It can be anything you want. I'm going to make a stick figure. Okay, so I'm going to make a stick figure that has at least 6 key points, and then I'm going to make it 3 times as large. So I'm going to make it down here. So here's my stick figure. Very simple. I'm not an artist. Okay, there's my original figure. Now I'm going to pick 6 points in there that I think define this figure. So I'm going to pick 1, there might be more than 6, 2, 3, 4, pick the top of his head, pick the bottom of his head, and I think I'll pick this point and this point. So I think I've got more like 1, 2, 3, 4, 5, 6, 7, 8 points. That's okay. Now in order to make this work, let's go look at the directions again. We want to draw the image with at least 6 points and dilate it. Now I need to choose a point of dilation. Just like here you were given the point of dilation, well, we get to choose. If I want my image to go in that direction, I'll put the point down here. If I want it to go in that direction, I'll put the point right here. If I want it to go straight up, I'll put the point down here. Okay, I'm going to go by what I have on my paper right now, and I have more room in this area, so I'm going to put the point over here so it goes in that general direction. Now I'm going to make the dilation so that he gets 3 times as large. So this, I'm going to call this A, B, C, D, E, and F, and I'll call this point G. I'm just going to draw lines through each of those points. So I'm going to pause the video and draw lines through each of those points. Okay, there's my lines. Now, I said there were 8 points, but there's only 1, 2, 3, 4, 5, 6, 7 lines. That's because I got kind of lucky, and from the point that I choose down here, by the way, I gave that point a name too. That's the point that it's being dilated from. That went through D and E on the same line, so I didn't bother making a second line there. So you might get lucky with your drawing too. All right, now we're going to take this, and we want to make this 3 times as big. All right, right now, when I take my measuring paper, and I could have made the point closer, by the way. This is going to make it a lot bigger, a lot farther away when the point is farther. But I'm going to make this 3 times from this point. Let's see, from this point I've got right there. So here's a dilation of 2. I don't need to actually record that point. And now I think I went a little bit too far, but I'm just going to go with it anyway. There's my 3rd point. So there's my, that was F prime. So there's F prime, even though it spills a little bit over into the other problem. Now I'm going to do the same thing with my C, which is the left hand. So I'm going to go from the point here, and let's go with 1 there, and then 1 more there. That's a lot less far, and that's my C prime. That's my C prime. Okay, now I need my G prime, which would be the bottom of his head. So I'm going to go from, I think I'm going to use the other side here. I'm going to go from P to G, mark off that distance, and then here's twice as far, so that would be making it twice as big. And now we're going to go 1 more, and then there is my G prime. Makes me wonder if I did my F prime right, because it seems so far. I'm just going to do that one more time and check that. So my F prime goes from P here, so that's a 1-to-1. When I go there, that's 2-to-1. And yeah, it looks pretty good. Okay, I guess it's just farther. All right, let's do E, D and E. We got to do both of these. So let's first do D. So D, even though they're on the same line, we need to do both of them. So D would be this far in my original. So I go 1, 2. So there's my D prime. And then E prime, even though it's on the same line, I've got to record it. I've got to still dilate it. So right there. And then there's 1 here. And then 1 more here. Uh-oh, I forgot which one it was. There, it's that mark. Okay. So right there. So there's my my E prime. All right, let's see what we get. Let's keep going. Let's get D prime. I think I'll use this side of the paper now because I'm already getting a little forgetting which one is which. So D prime is this far. So I go there and there. So there's my D prime. I'm going to pause the video. Okay, I've got all of my points. I named them all. I know that D connects to the 2 legs, so I'm going to go ahead and connect that. I'm using a little different color so that I can tell what I'm doing here. Now, I realized something that I might have said wrong earlier in this video, and that's that the lengths are actually twice as big. From that point, it depends on the point. So wherever this point is, it might not be twice as big. So we're not going to actually go by that. I'm not going to ask you that anyway. I just want to see the dilation. Okay, so then D prime, now I call this D prime, but this is, oh, I missed a point here. That doesn't have a name. That's not D prime. So that's just a nameless point because it seems like I forgot to name it. So I'm going to give it a name. I'll just call it T right here. This would be T. This would be T prime so that it has a name. And then T prime connects to D prime here. So straight up there. Looks like it got a little bit slanted. All right. And then that connects to E and to C. And there's my enlarged dilated image. Hope you found this helpful.